Okay, question 5. The figure shows a uniform ladder 3 meter long and has a mass of 30 kilograms. So the ladder is at rest with its upper end against a smooth vertical wall and its lower end on rough ground. So we have to draw a free body diagram of the system and show the forces acting on it. Find reaction force at point A and point B, and then calculate the least coefficient friction between the ground and the ladder. Lebih-lebih pula bunyi dia. Okay, so firstly let us draw the situation. So this is the wall, and then we have the ladder to be something like this. Okay, and then this is the angle here, 50 degree, and then this is 3 meter long, 3 meter. Okay, so again the ladder is a uniform, we can consider it, look at it as a uniform beam. So again the weight of the ladder will be at the center of gravity, and then there will be a reaction force. Actually I'm not gonna draw this line here sebab kacau. Okay, so there's reaction force at point A, this 90 degree to the surface, and then point B pun ada juga. And then we have to also consider the friction force. Again, the ladder will have a motion only in the x-axis, and then this is gonna be the chances of moving is to the left lah. The chances of this ladder moving is to the left sebab dia stuck di sini, tapi di sini dia ada je possibility untuk move kan. Okay, so the friction force will be going against the motion. So that is the direction of the friction force. This is the weight force for the ladder. This is center of gravity, remember, CG, and then this is the reaction force at point B. This is reaction force at point A, and then this is the friction force. Okay, so it is static, so static friction force lah. Okay, alright, so that is the free body diagram. Now we can then calculate the reaction force at point B dulu. Okay, so at point B we can calculate this by using the vertical component. So total force at Y is equal to 0. So we have RB minus mg equal to 0, which give us the reaction force at point B to be equal to 294.3 Newton. Okay, lepas tu we have to find the reaction force at point A pula. Okay, sekarang ni we are gonna use the formula net torque. Okay, so the torque at point B is equal to 0. Okay, we are gonna let point B to be the rotation axis. So everything kita akan tengok this point. Okay, so RA, kita tengok RA dulu. RA ni anti-clockwise. So since they're anti-clockwise, dia punya perpendicular distance pula is this one. Okay, so perpendicular distance dia ini. So anti-clockwise pula tu, so they're positive. So how do we find the distance? Is by using Pythagoras theorem ataupun trigonometry. Kamu guna trigonometry lah. Obviously trigonometry. Okay, so in this case, I'm gonna label this as L. Okay, the distance yang kita mau untuk RA ni, the perpendicular distance that we need. So this is 50 degree. This is 3 meter. Okay, so this from here up till here is 3 meter. Kita mau distance yang ini saja. Okay, so how do we do that? It is we can use sine 50 degree equal to opposite, which is L, over the hypotenuse, which is 3. So L is basically 3 sine 50 degree. Okay, so dia punya distance is 3 sine 50 degree. Okay, lepas tu kita tengok pula untuk the beam punya weight. So the beam is here. So this one is clockwise. So if it's clockwise, it is negative mg. Kamu faham kan clockwise anti-clockwise ni? It actually means the tendency of this force to rotate to this point B is clockwise. Okay, so clockwise macam tu. Okay, so that's why the negative mg. Lepas tu kita perlu cari juga distance dia, perpendicular distance dia. I'm just gonna use purple. So this is the triangle now. Okay, there's still 50 degree di sini. So 50 degree, and then the length, the perpendicular distance is, kita letak sini. So this is the perpendicular distance yang kita mau. Okay, so the perpendicular distance is at this point. I'm gonna write it as LM lah, LMG. Okay, LMG. Lepas tu kita ada tadi dari sini pergi sini is 3 meter. Okay, tapi sekarang kita mau tengok from here point B until this center of gravity je. So we divide by 2. This is 1.5 meter. Okay, so this is 1.5 meter. Okay, so what angle can we use is we can use cosine. So cos is 50 degree equal to adjacent over hypotenuse, which is LMG, over hypotenuse, which is 1.5. So basically the perpendicular distance is 1.5 cos 50 degree. Okay, so substitute lah dalam ni 1.5 cos 50 degree. Okay, ada lagi any other forces? Tiada, sebab yang ini kita tidak boleh consider both this because it is at the rotation axis. So automatically dia akan equal to 0. Okay. Okay, so this is equal to 0. So this one you can calculate, rearrange. You should get the reaction force to be equal to 123.47 Newton. Okay? Okay, so that is question B. Finally, question C, we have to find the coefficient of friction. In that case, we are going to use the x component. Okay? So the x component is total force at x is equal to force, the frictional force, minus dengan RA. Okay, so this is gonna be equal to 0 sebab dia in equilibrium. So basically this frictional force is gonna be equal to the reaction force at point A. Okay, so yang ini ni, we know that the friction force is equal to mu n. Okay, mu n. Basically, the value of normal force yang kita akan tengok is the value at point B lah, the normal force at point B. Okay, and B ni basically equal to reaction force at B, point B. Okay, so Fs is equal to RA, which is equal to 123.47, equal to mu, and B is the reaction force at point B, which is equal to 294.3, which gives you the coefficient of static friction to be equal to 0.4. Alright? Okay. Wow, that is very long, kind of long, or did I just talk too much? But never mind. So this is the solution for question number